going to give two methods for this question. First of all, I'm going to stick with the kind of form it's in. In the second one, I'm going to write it in powers of 10 and create Diophantine equation. But more on that in a minute. Right, let's look at the first column. I'm adding O together 3 times. So 3, I'm going to make this O kind of exaggerate it so you can see it's not 30. So 3O must equal, well, it could equal O itself. Or 3O could equal O plus 10 if I carried it across. Now in this case, I'd get O equals 0. And in this case, I'd get O equals 5. Or could I actually have 3O is O plus 20? No, I don't think I could, because then I would get O equal to 10, which is not possible. So we found sort of two different avenues, basically. Let's look at case 1. O equals 0. Then I've got JM. Now this is actually a 0. And that will be a 0 as well. So I can do exactly the same thing with M, except we're told that different letters stand for different digits. So in this case, M must equal 5 using reasoning above, because it must be that 3M is equal to M or 3M is equal to M plus 10, but it can't equal M because M can't equal 0. All right, that's really good. So let's write it out again. J5, 0. So here I've got 15, so I'd get a 5 and I'd carry a 1. Therefore, we've got 3j plus 1 must equal I. So we could have j equals 1, which would give I equals 7, or j, wait, that's not right. I equals 1 would give 4, sorry. J equals 2 would give I equals 7. And j equals 3 would give I equals 10, so no solution. So as long as you're sort of explaining along the way why you haven't missed any solutions out, why, that we can stop there, then I think that should be okay. And we found our first set of solutions then. So we're going to have, what was it, 1, 5, 0. Okay, that's an option. And that is another option. But remember, this is for case 1. So now we need to look at case 2. And remember, that was when O is equal to 5. Okay, let's see what happens. So here I'm carrying 1, so I've got 3m plus 1 equaling, well, it can't equal m because, yeah, m would have to be a negative then. So reject that one. So it's going to have to be m plus 10. But then I'd get 2m equals 9. That's also not possible. And I suppose we could try 3m plus 1 is equal to m plus 20, but we're going to get into similar difficulties. 2m would then equal 19. Okay, so no other solutions. Therefore, by logically working through, like saying that O has to be 0 or 5, I've tried to explain why, and then using similar logic, well, case 1, O is 0, showing that M is 5, and then getting the different scenarios for J and I, we found two solutions. And then case 2 was to try O equals 5, which we get no other solutions. So that is a solution method, and I think it works pretty well. So that is how I did this question. Let's take an alternative path through this question now. So, and it's worth being aware, like sometimes it's easiest to use the approach that I used. I think it worked pretty well. Sometimes it's really helpful to write it using powers of 10. What I mean by this is say the number 317 is actually 3 times 100 plus 1 times 10 plus 7. So if we can take this, we can write JMO as 100J plus 10M plus O. And this gives, going to get 300J when I add all these together, plus 30M plus 3O. And that is going to equal 100I plus 10M plus O. And this is a Diophantine equation. J, M, and O and I, they have to be digits from 0 to 9. In fact, J and I can't be 0, but they have to be digits from 0 to 9. They have to be whole numbers. That's crucial. So what we can do first of all is rearrange 300J, and then I can minus 10M, so plus 20M plus 2O is equal to 100I. I'm going to divide through by 2. Okay, that's looking a bit better. Now, apart from the O, there's a common factor of 10. So if I divide through by 10, I get 15J plus M plus O over 10 equals 5I. This means that O has to be a multiple of 10. Remember, it's a digit between 0 and 9, so it's actually equal to 0. So now we've got 15J plus M is equal to 5I. And we can do a similar thing again. Now there's a common factor of 5. I can divide through, so I've got 3J plus M over 5 equals I. M must be a multiple of 5. And remember, M can't be the same as O because they're different, so M has to actually equal 5. Okay, this is going well. And then we get to the fact that I must equal 3J plus 1. And from there, we're basically there. We could have J equals 1, which implies I equals 4, or J equals 2, which implies I equals 7. And it can't go beyond it. Just make sure you write that down, because then it would equal 10. And we'd get this, hopefully you can see we're getting the same solutions. It's very different approach, but we're going to get these same solutions here and here. So I'm not going to finish writing that out, but yeah, that is the answer to this question. Well done.